The final presentation is titled Foam Glass Aggregate Use, Interstate 395 Route 9 Connector Project, is given by Erin. Erin joined Haley and Aldrich in 1998. She's currently a project manager and a senior geotechnical engineer, where she is responsible for the planning, execution of geotechnical scope of work for highways and bridges, buildings, and marine facilities. Erin served as the project manager and technical lead, the highway section for the highway that is being constructed as part of the Interstate 395 Route 9 Connector Project. She led a local and regional team of Haley and Aldrich staff through completion of the embankment technical evaluations, development and submission of design deliverables, and preparation of geotechnical related contract documents. She's also responsible for for overseeing various geotechnical related construction activities, including installation of prefabricated vertical drains, geotechnical instrumentation, and foam glass aggregate lightweight fill. Erin received a Bachelor of Science in Civil Engineering from the Tufts University and Master of Science in Civil Environmental Engineering from the MIT. She's an active member of Women's Transportation Seminar. Please welcome Erin.
Thank you. So this has nothing to do with the moon, unlike the earlier presentation, but when you look at the foam glass aggregate very closely, it might resemble the surface of the moon. So maybe that's the connection here. So I'm going to talk about foam glass aggregate. It's a lightweight fill material that is currently being used on the Interstate 395 Route 9 connector, just 15 minutes away from here in Brewer and Eddington, Maine. I've been working on the project for 5 years. As a geotechnical engineer, it's been a really interesting and exciting project, and a lot of fun for our younger engineers too. I think a really good learning experience. So I will touch on the project overview just because it is kind of important to this region. I'll talk about the subsurface conditions and how they impacted our foundation design, which necessitated the use for the lightweight fill. I'll give a little information about lightweight fill and then show some construction photos. And I guess unlike a lot of the other discussions today that were really research focused, I think this is kind of past research at this point, and sort of we're really in implementation. So kind of further along in the process on this one. Oops. So the project itself right now, Interstate 395 ends at Route 1A in Brewer. But there is truck traffic that wants to continue through to Route 9, which runs east towards the down east Maine region. So this project is a 6-mile connector from the end of 395 up to Route 9. It'll provide more direct traffic routes for truck traffic, safer movement of traffic, and keep traffic off of some of the local roads where it currently has to go through Brewer and Eddington. Maine DOT looked at a ton of alignments through this area. This is the selected alignment. You can see it goes through, woods, fields, crosses a number of roads, streams, and connects. So Route 395 is down at the bottom here. And then that orange line is the new alignment up to Route 9 at the upper right. So the project team, Maine DOT is the owner, and they did basically all of their own bridge and highway design along with right-of-way and environmental permitting. They did hire us, Haley and Aldrich, as the geotechnical consultant, and we worked closely with their structural people and their geotechnical people to work on the geotechnical aspects of this project. The contract was awarded to Sargent Corporation for about $84 million. And they have hired, or they're getting their foam glass aggregate from Aero Aggregates, which is a supplier out of the Philadelphia area. And actually, if you've noticed in the news, the discussions of the Philadelphia bridge that had collapsed earlier this year, Aero Aggregates provided foam glass aggregate to fill that span in and get the roadway opened temporarily. So they were kind of instrumental in that project. So the project, as I mentioned, it's 6 miles long of new roadway, which is a little unusual these days. There are embankments over compressible soils, which is really the focus of what I'm talking about today. So there's these 3 areas that we're calling special embankment areas. But in addition, there are roadway crossings, snowmobile, stream, wetland, and wildlife crossings. The timeline, it started all the way back in 1998 when the DOT and FHWA began a corridor study. An alternative was chosen in 2016, and then the design team started work in 2018. Final design was complete and the project was advertised in the fall of 2021. And then construction started in January of 2022. So it's ongoing now. We're really in the throes of it. And it's on schedule to be complete in July of 2025. So we did a lot of subsurface explorations. We did borings and geophysical testing and CPTs. I think we had 250 borings or something along this alignment to fully characterize everything. Generally, though, the conditions in the upper right figure, the pink or purple colors are the Przemysl formation, which is the clay that causes some challenges for us. And those are generally in those lower lying areas if you're looking along the alignment on the bottom. And then in the kind of green areas or the higher elevations, there are glacial deposits. So we have fills over soft ground and then cuts in the glacial till and rock. So kind of hit the full range of geotechnical conditions here. This is just one typical piece of a profile just to show the subsurface conditions. Here, there's it's coming off of some of the embankments at the southern end of the project. So we're placing new fill to kind of meet those existing embankments, and that's being placed over this marine deposit that is fairly soft as the blue deposit there. And then below that is glacial till and bedrock. So I guess as far as the general process went, we sort of identified actually 4 areas that had clay. It was 34 feet of fill or up to 34 feet of fill over a range of clay thickness, but up to 42 feet. Through the process of the preliminary and final design, we were able to eliminate one of these areas. So only 3 required some special construction. We assembled all our field and lab data, selected soil properties, which were specific to each area. And then we performed settlement evaluations and compared them to the project criteria that Maine DOT had provided. We also performed global stability evaluations, both temporary and permanent. And the temporary evaluations actually controlled the design in many areas because we couldn't place the full height of embankment fill and have the embankment be stable. So we needed to place a part of it, let the strength or the clay gain strength before we could place the full height of fill. So that definitely impacted some of our design decisions. This is just a summary of some of the soil conditions in one area. It just kind of shows the magnitude of data that we had from both in situ field testing and lab testing. And then for geotechnical engineers, the selected undrained shear strength kind of ranged from 400 to 600 PSF in the clay at this particular location. So fairly low strength clay. So the approach that we selected is primarily a preload surcharge program with basically placing fill, letting it sit for 9 months, getting that settlement out before you construct the final roadway surface. But we needed to do some load balancing because we couldn't place all the fill at once. And we also, sometimes you can have a second hold period. So place fill, let it settle, and then place a second stage of fill. But the project schedule didn't allow that. So in our second stage, instead of placing all normal weight fill, we did a combination of normal weight and lightweight fill. So the program includes prefabricated vertical drains installed through the clay, which accelerates consolidation. As I said, normal weight fill for stage 1, and then normal weight and lightweight fill for stage 2. And then we're monitoring performance of the program with geotechnical instrumentation. We used, there were 2 culverts where the sequencing didn't let us put the wick drains in. And so it made more sense there to use a full height lightweight fill. So the entire embankment is constructed of lightweight fill adjacent to just those 2 culverts. And then the selected lightweight fill option is foam glass aggregate. Here's a typical cross section. So basically during the initial fill placement, you'd place it up to the red line here, normal weight fill, let it sit for the 9 months or so, and then excavate back down and place lightweight fill sort of in that yellow area. So the finished embankment, and that detail varies along the length of the embankment, but you end up having this lightweight fill in the upper portion of the embankment. Here's a profile through the 2 culverts I mentioned. So here the lightweight fill is included for the whole height of the embankment, except for the roadway section on top. So there is about 2 feet of normal weight gravel and the pavement on top of the foam glass aggregate. So the next group of slides, Aero Aggregates provided, and I'm really, they're the ones producing this and really have the data. So I want to give them credit here. Archie Filshill is their founder and CEO, and is always very happy to talk about this product. So anyway, he's provided me this information. So this is what it looks like. Those aggregate pieces are about 1.5 inches in diameter. But it really is not that different from a normal aggregate. It's just a very different weight. And it has definitely different properties. So here you can see it weighs only 15 pounds per cubic foot compared to normal weight fill is 120 to 130 pounds per cubic foot. So really helped with our settlement challenges on this project. And it has a very high friction angle. So they have test results that show it has a friction angle of about 54 degrees. We did not use that high of a friction angle, just given that it was a little bit new to us and new to Maine DOT. In addition to that, it's a good insulator, it's frost resistant, and it's very free draining. Some of the earlier applications of the product were for some of these other reasons. So the process of making the material, they start with recycled glass, just normal bottles and jars that we all recycle. They remove any paper or metal or anything on it, and then they kind of pulverize it into a very fine powder. And then they mix in a very small amount, like 1% of foaming agent, which is also a powder. So they have this mixture now of powder that they lay out on a conveyor belt in sort of a thin layer. And then that passes through a kiln that it softens the material, and he described it as sort of like baking a cake. So the other side of the kiln, the conveyor belt comes out with sort of a cake-like material. And in the heating process, that foaming agent has now created bubbles in this material. So it comes out in kind of a sheet with bubbles. And then when it hits the cooler air inside the facility, that causes it to crack. So they don't need to do anything to process it and crack it. That just happens with the thermal differences. The product primarily started in Germany in the 1980s. In the 90s, though, Norway started using it as a thermal barrier, so to prevent frost heave. And then that sort of led to these lightweight uses or applications. So this just shows some of the applications. The top half are the infrastructure applications. So like we're using at Brewer, we're using it for embankments. We've also used it behind retaining walls and bridge abutments to reduce lateral loads on abutments. You can use it to backfill tunnels, culverts, and utilities. The material, when it's placed in the field, rather than measuring compaction like you would for a normal kind of sand and gravel fill, it's really placed kind of using this method spec, meaning that we define certain lift thickness and means and methods, and then use that throughout construction. So what Aero Aggregates recommends, and we're using on this project, is 24-inch thick lifts, and then 4 passes of some excavation equipment or site equipment. And they have a certain pressure range basically that they want that equipment in. So like you don't want something too heavy or too light to kind of like target this this spot of compaction. It's nice. It requires less compaction than normal aggregates, and it's thicker lifts. So it's kind of less on-site handling and compaction compared to some materials. These are just some guides. A lot of the guidance for using it in the US had initially come from these Scandinavian guides, and then kind of it's been adopted here. This is some direct shear testing results, which just show that it has a friction angle of 54 to 56 degrees. I'm sure Aero Aggregates has tons of strength data. It's just an example. And they've also done some electrochemical testing to show that it's compatible for use in MSE wall backfill and doesn't cause degradation or any problems with the MSE wall reinforcement. The material's been approved by a lot of DOTs, the states here shown in blue, along with a bunch of other agencies. And then these hatched blue areas are places that they're in the process of getting approval for. So as far as the Route 9 connector construction, it's underway. Last fall, we placed foam glass aggregate in the 2 culvert areas where we had the full height fill, and then places where we're putting it within the embankment sort of during the second stage are ongoing right now. The total volume we estimate will be around 77,000 cubic yards in place, which is over 100,000 cubic yards delivered. Aero Aggregates has said that this is the largest FGA project that they're aware of in North America. And there's a statistic there about diverting 90 million 12-ounce bottles from landfills. Before construction, we did do a test pad. So when they first started importing the material, Maine DOT, Haley and Aldrich, and Aero Aggregates had staff on site to kind of do a test panel so that people could see the means and methods and how the material behaved. So that defined equipment and lift thickness and number of passes. So then throughout the remainder of the project, we've been following that same approach. Here are some pictures. It comes in really large trucks because it is so light. It's not limited by weight on the highways. So they can deliver quite a lot at once. You can see in the truck on the right, it's standing up almost vertically in the truck. So it is just kind of demonstrates the kind of high friction angle that the material has. You can also get it delivered in bags. So you can use this product around foundation walls or some other applications. So there are times you may want, might be easier to kind of do smaller quantities like this. So at the start of our project, they did do some of the areas just to start with the bags. You can see the excavator can pick it up and a laborer can kind of just cut the bag open. On the subgrade, before placing the foam glass aggregate, we did put down a geotextile to separate the clay from the coarser aggregate size. And here are 2 pictures just of the equipment applying compactive effort, kind of like normal construction equipment. And there were a few details we had to work out. So on the left there is an area where they're going to have guardrails along the edge of the highway or along the edge of the ramp. And so the initial details would have had the guardrails penetrating through gravel, through the geotextile and into the foam glass aggregate. So we made some adjustments to the thickness of the FGA along the edge so that the guardrail could sort of be all in normal material. The photo on the right just shows us the sides of the embankments. We have placed geotextile again over the sides and then riprap over the side of that. And for some environmental reasons, it's kind of soil filled riprap, not just plain riprap. These I'll skip over. And that's it. This is one of the areas last winter when it was sitting there settling, and we were monitoring instrumentation. We have some instruments there kind of under the embankment and on each side. And then right now this week they started placing FGA in this area.